Hi, in this video I'm going to do some very basic comparisons between Microsoft SQL Server and typical big data solutions. Now the reason for this is mainly because there's recently been more of a pushback in terms of what big data means and what people can do with it. And I've been discussing this for a long time with many of my colleagues as well as participants in my trainings, where a simple example would be companies come to me saying that we need to implement big data solutions. And typically, one of the things that I ask them is, so why do you think you need big data solutions? And usually their answers would be something like, we've got hundreds of gigabytes of data, or we're dealing with a lot of unstructured data, or we need data processing to be very fast, and we need our reports to be very fast. So the thing is that as far as most companies are concerned, these things can easily be achieved using SQL Server as well. It's usually the implementation where people make the mistakes. So what I wanted to basically try and highlight here is that SQL Server as a tool is capable of handling very large volumes of data, and it's also able to handle that very efficiently considering the amount of data that comes in. And also as far as the variety is concerned, which is basically the V's that we call for big data solutions, which is basically velocity, volume, and variety. And all these three can actually be handled very easily within SQL Server if you just implement it right. So that's essentially what I'm trying to do here today in terms of comparisons. For example, if you would think about volume, uh, most people might disagree in terms of whether 100 gigabytes is in the scope of big data or in the scope of normal SQL Server relational databases. That would be more in favor of big data if you were talking about things in the terabyte scale. But most people would definitely agree that if you're looking at a petabyte of data, then you're definitely talking about a big data solution. But contrary to popular belief, what you'll see here is that this is again one of the recent most examples being discussed. So you can see here that NASDAQ actually manages over a petabyte of data using Microsoft SQL Server. So you can see if you just Google NASDAQ SQL Server, you'll see the video where you can see that basically it's just a video explaining some NASDAQ executives talking about how they've implemented SQL Server to manage a petabyte of data, and they're getting very good performance out of it. You'll also have the Microsoft case study here from the Microsoft link, so you can download this, which explains exactly some of the more finer details in terms of how this implementation was actually done. So this would be a very good example of how SQL Server can actually handle volume. And as you can see, it's a petabyte of data. So what we're basically looking at here is the fact that SQL Server can handle a very large volume of data. The next thing would be the fact that SQL Server can handle velocity. Now, velocity means basically the rate at which data comes into the system. Now, traditionally, this hasn't been one of SQL Server's strong points because of earlier implementations where disk latency was one of the biggest factors, and also the implementation of the transaction log file, which is actually a sequential write. So velocity was obviously one of the challenges as far as SQL Server is concerned. But for a lot of the people who have been working with SQL Server for a long time, you'll notice that there is a feature called Stream Insight, which can be used for low latency, high throughput event processing. Now, event processing basically indicates something like being able to perform some business logic on some input data, and then as a result of it, perform some output activity, which is basically the most common example we use is sensor data. A sensor data basically monitors hardware located in maybe different parts of a factory that monitors things like temperature, humidity, etc. And then if any of these thresholds are crossed or any of these values cross a threshold, it takes corrective action. So that kind of ability in terms of being able to handle a very large volume of fast data and immediately consider the implications of it and perform some corrective action is one of the reasons big data is being used quite a bit, especially when it comes to GPS related activities. But the fact remains that this functionality called Stream Insight has been available in SQL Server for quite some time now. It's actually been there since SQL 2008, as far as I remember. So we have this ability as well in SQL Server, but more importantly, this is talking about event processing. on the other hand, if you just talk about being able to insert large volumes of data into SQL Server, then in-memory OLTP tables have the ability, especially when combined with natively compiled store procedures, to give you that kind of functionality. A simple example would be, I'm right now working on a logic here inside SQL Server, which essentially the purpose of it is to go ahead and calculate the glide slope and the autopilot configuration for a jumbo jet aircraft on its final descent into an airport. Now, obviously, this requires some background in terms of what pilots do on final approach to an airport. But essentially, what happens is that you define your altitude, your speed, and the distance that you have, or the DME from the target airport, and then the autopilot essentially corrects or configures the aeroplane in such a way as to land in the best possible way. So what we're looking at here basically is just a store procedure that does that calculation. So if I just do set statistics time on, let me just go ahead and connect. You'll see that I've basically given a typical approach, which is about a standard 3-degree glide slope at an altitude of 3,000 feet and 10 nautical miles from the airport for a jet traveling at 185 knots. Now, if I go ahead and execute this, you'll see that basically, just a second, let me just go ahead and use the database. You'll see that basically what we're doing here is that I've actually gone ahead and executed this procedure, and it took about 118 milliseconds. But in that 118 milliseconds, what I've actually done is calculated for every microsecond the distance and the altitude the plane should be at from the time that we configure this value all the way till the time that it actually lands. So you'll see if I just order this by RID, order by RID, and if I scroll right down, you can see it's quite a bit of data here. So you'll see that we start off with 3,000 feet and then we go right down to 0 feet, as well as 0.0004 feet of altitude. The reason I'm showing you this is because essentially what I'm trying to prove here is that SQL now has the capability to handle very large amounts of calculations, as well as perform very large amounts of inserts into database tables. And what that essentially means is that real-time operating systems where we have calculations done dynamically on the fly is actually capable, or is actually possible now within SQL Server. I'm not necessarily saying that that's the way to do it, but the idea being that SQL Server is now fast enough where you can actually implement complicated real-time logic and actually have them execute fairly quickly. So that's basically about the velocity part of it. And the next thing is obviously variety. Now, when it comes to variety, SQL Server has been fairly good in keeping up with the changes or the way the people have been working with data. So we obviously had rows and columns, and after rows and columns, we then moved on to XML. We went into file stream and basically unstructured data in terms of documents and resumes, where we could go ahead and insert resumes and then query resumes for keywords and things like that. So SQL has been always fairly in step with the way that people use the data. Obviously now we have geometry and geography as well. So as far as variety goes, SQL Server obviously has that also pretty much under control. I wouldn't say necessarily it's as good as big data solutions that we have out there, but it's definitely in the same ballpark as far as typical use case for most companies are concerned. So at the end of this video, basically what I'm trying to say is that SQL Server definitely has the capability and the functionality to work with most big data scenarios that companies are likely to encounter. Obviously, I'm not saying it's a replacement or it's the alternative for big data. There's definitely use cases where big data solutions, be it on the cloud like HD Insight or on-premise systems. But the intention here is that a lot of companies are confusing their existing infrastructure and data volume as a use case for migrating to big data, and that's a wrong step in the wrong direction. I would say, because you need to understand that big data obviously is a completely different technology, and it's probably an additional layer of IT that you're going to add on top of your existing infrastructure. So before you consider that, the question would be, have you actually utilized your existing infrastructure to the best possible way? And hopefully with this particular video, I've actually maybe put some basic groundwork in terms of that. And in my next video, what I'm going to do is I'm going to show you how SQL Server can handle variety, which is, I think, probably the biggest challenge when it comes to helping customers migrate from traditional RDBMS to uh, big data solutions. Obviously, this was a theoretical video in terms of what can and cannot be done, but I hope you've enjoyed watching it, and thank you for watching.